passive.
It's actually. Oh, sorry, I just muted for one second. Okay. So, the difference between active and passive, it's pretty, you know, um, what's happening? Why am I forgetting words? Okay. It's a very big difference between active and passive. And the entire difference, it depends on one thing. Are lymphocytes activated? And do they produce
Okay.
memory cells? If you have memory cells which are being produced, if you have any kind of
Okay.
long-term effect from a vaccination, it's an active vaccination. If you have
Got
a
it.
short-term effect, if no memory cells are being produced, then it's a passive vaccination or a passive immunization. Now, one more problem. Active antigens, right? Because you're producing memory cells, you need to actually activate the system. You need to activate the immune system. Now, to activate the immune system, majority of the times what we do is we just give them a live attenuated vaccine. Now, what a live attenuated vaccine is that basically it's a semi-killed version of the bacteria which you inject,
Yeah.
and because it's a semi-killed version, your body still has the ability to like put on a good fight. But even if the infection were to get severe, you won't get affected because it's half killed. Devanshi, I will mute you for some time. There's a lot of
Yeah. Sorry.
voice on your end. No, that's all right. No problem. So, yeah, that's the difference between active and passive immunization. Passive immunization is when you directly give the cure. Okay, I'll use an analogy here so it becomes a little easier. Active immunization, or sorry, a passive immunization is when you directly give the cure to someone. This could be preformed antibodies, which will directly kill the bacteria, or this could be an antitoxin, which will directly neutralize the toxin. On the other hand, in active immunity, you need to activate your own body to produce the cure. This could be an infection. Let's say you had an infection, your your body fought against the infection, and now it knows how to treat the infection. So that is active. Let's say you got bit by a snake, and now your body is trying to produce the antivenom. So that would be active. Or okay, technically, if you get bit by a snake, you'll probably die. But let's say we take the snake venom, we kill half of the toxicity, and we make it like safe. We convert a toxoid, and then you take the toxoid. Now your body has the ability to make its own antivenom against the toxoid. Now the beauty of this entire process, right, is that if you make anti-venom or let's say antibodies against a half-killed bacteria, you will still retain the effects against the complete bacteria. So let's say we took chickenpox, we boiled the chickenpox virus, and now they're almost dead. We inject someone with chickenpox virus, which is almost dead, the live attenuated version, and they develop an they develop an immune response, and now they're immunized against chickenpox. Now, when the actual chickenpox virus comes in, even though it's much stronger than what the vaccination was, because it's the complete virus, even though it's a complete virus and it's much stronger, your immune system will still be able to deal with it very efficiently. So much so that you won't even have any symptoms. So, did you guys understand the difference between active and passive immunization?
Yes, I got it.
Perfect.
The way now I need to think. I got that. Thank you so much.
No problem. And now let's talk about one very important branch point. Uh, why is it bad to give why is it bad to give active immunization in someone who has immunosuppression? What do you guys think?
Mm, but sometimes. the patient can get the disease more quickly compared to the one who has immunity, like proper immunity, because uh, his or her body would not be able to react to that killed, even the killed virus.
Yes,
The
that is
symptoms
correct.
which
So
they produce
even,
won't
yeah,
be able to.
no, that is 100% correct. Like what happens, right, is because your body's immune system is already like very low. Even a small infection, even a half killed virus, can have the same effect as injecting them with a live virus. That is why we want to prevent active immunization in anyone who has immunosuppression. So now we can't give them active immunization. So what do you think? What other mode can we? Yeah. So now we cannot give them active immunization. So what do you think? What other thing can we do to treat these patients if they develop an infection?
Give antibodies?
Yeah, we give them antibodies. And now antibodies are directly the cure for the infection. So they are considered as passive immunization.
Okay,
Yeah. So that's the idea behind passive immunization.
now I got it.
Yeah. Now, speed is also an issue. If
Yeah,
someone
that's
has,
also important.
yeah. So if someone wants a much more rapid cure, you give them passive immunization because it's the direct cure, but it will last for very short time. But if you give them active immunization, it will take time for your body to actually adapt and kill the virus and then, store that memory. But once your body stores the memory, you will have that memory until the day you die. So it's very long lasting. That in general is the difference between active and passive immunization. Now, here I'll tell you an interesting thing. If you only remember what these vaccines mean, if you only remember that, it's very easy to like complete this entire like table. You don't need to remember what the pros and cons are. The USMLE doesn't ask you about that. You need to remember these examples, but this is pure memorization, and you'll do all of this in microbiology. So now let's go with the types of vaccines that we have. First, we have a live attenuated vaccine. This is the vaccine where I was telling you that the bacteria or the virus, it's half killed. So it's still alive, but now it's weaker. So live virus, but weaker. On the other hand, a killed or inactive vaccine is when you've completely killed the bacteria or virus and now you're injecting it. Next, we have a, you know, I would say a group of these vaccinations, which is subunit, recombinant, polysaccharide, and conjugate. All of these, even though they have different names, they pretty much mean the same thing. And what they mean is, let's say you have a HPV virus. Now, to recognize that virus and to produce memory cells, you don't really need to give these patients the live attenuated vaccine. Why? Because you can take a small protein from the membrane of the virus, or it could be like a small protein from the DNA. You take that small protein, you attach it to another protein to, extend its effects, and that is what a recombinant medication is, or a recombinant vaccination. It's a small part of the entire virus or the entire bacteria instead of having the entire virus. So I would say it's much more efficient. But the problem is that because it's so efficient, because it requires very specific proteins, it's very expensive. And it has a weaker immune response because obviously you're not fighting against the entire bacteria, so a response will be weaker. So any questions until this point with these three?
No.
Okay. So next we have these two. We have toxoid and then we have mRNA. Now these are pretty much as the name says. If you take a denatured or like a killed or a weaker form of the toxin, of a bacterial toxin, that's called a toxoid vaccine. And if you take an mRNA from a virus or a bacteria, that will be an mRNA vaccination. And the vaccination that a lot of us took in the last few years was the mRNA vaccine for the COVID-19 infection. So, what do you guys say? Any questions about immunization, active versus passive, or any of these types of vaccinations?
No, not yet. Once we will solve questions, I'll ask you.
Yeah. For
Now it's good to go with the few mistakes which I was making. I got to know how to like think about it.
yeah,
Thank you
and
so much,
then
sir.
no problem. And then one thing I'll tell you is to remember these examples, because a lot of times they will ask you
Which
that
one?
these examples. So live attenuated adenovirus,
Adenovirus type.
typhoid, polio, the Sabin vaccine, because polio also has a killed vaccine, which is the Salk. So you need to remember these because sometimes they'll give you, let's say they give you polio. They tell you that a patient was given a live attenuated vaccine for this condition, and what was the route of administration of the vaccine. Now, the killed vaccine, it has a different route of administration. The Sabin vaccine, it has a different route of administration. So you need to kind of think about those things.
Okay.
Yeah. I believe, yeah, Sabin is the oral drops, and then the injected one is Salk.
Okay.
So next we have the hypersensitivity reactions. Now there are four hypersensitivity reactions, and it's sorry, it's pretty easy to understand them. And there's a so you don't need to remember all of these, but I'll try to simplify these for you. So type 1 hypersensitivity, the one thing you need to remember, which is the most, if you forget everything else, that's all right, just remember this one thing, that it is IgE mediated. Now let me ask you guys, which cells produce IgE?
Maybe
T
mast
cells?
cells?
Yeah, Mars cells can produce it, and a majority of the times it's the Mars cells which are producing IgE. So now, what happens in hypersensitivity reactions or allergies? Initially, you come across a bacteria. No, not bacteria, but a molecule. Let's say it's a dust molecule or a dust mite. The dust mite somehow enters your nose. The cells in your nose, or the mast cells which are in your nose. Sorry. Yeah. So the mast cells which are in your nose, right? They think about the dust mite as a foreign particle. So now they're already like on alert. They're like, okay, if another dust mite comes in, we will mount a response, like an immune response. Okay, so that's the first thing that happens. This is called the pre-sensitization or the sensitization. So the initial cell would be pre-sensitized, and then after the first encounter with the dust mite, the cell will be sensitized. Now, what do you think will happen if the same dust mite comes in contact with the mast cells again?
Uh, See an immediate response
Yeah, they'll
from the
just go
pre-found
nuclear.
He'll
IgE.
react.
Yeah, they'll go nuclear. They'll just be like, yes, we found another dust mite. We'll just release all our histamine. Will release all the all the IgE that we have saved up. Will release everything. Now, usually they don't go that nuclear. They don't go complete like crazy. They maintain it as a normal immune response. But sometimes when they do go complete nuclear, when they just go complete like crazy, and they release all the histamine, they release all the IgE, that is what you call as anaphylaxis. Normal allergies are when your mast cells are still controlled, and if they're presented with another of the dust mite, which we're using as an example, if they're presented with another of the dust mite, they just go like, oh yeah, this is something we need to take care of. Let's mount a normal response. And anaphylaxis, just everyone starts degranulating together. Now, because there's so much histamine, because there's so much immunoglobulins, you have a immediate decrease in blood pressure. Now, the immediate decrease in blood pressure causes shock. And that is why whenever we say anaphylaxis, we usually use the term that patient has anaphylactic shock. Now, because you have a lot of IgE, or rather, like because you have a lot of immunoglobulins, those immunoglobulins will attract immune cells. Leukocytes will come in, macrophages will come in. Now, what do you think? What will happen if more immune cells come towards the site of the site where mast cells degranulated?
Kindly repeat the question.
Yeah. So let's say at the site of inflammation, where mast cells came in contact with the dust particle. If there's a lot of immunoglobulins and if there is a lot of lymphocytes which migrate to that area, so then what do you think will happen around that area?
It would be raised and warm and red. Maybe.
Let's say think about swelling. A lot of cells are coming in, they're bringing a lot of fluid. So you'll have a lot of swelling around that area. And this is one of those reasons why you get laryngospasm during an anaphylactic episode. So laryngospasm because of anaphylaxis. Next, we have the type 2 hypersensitivity reaction. Now, type 2 hypersensitivity reaction, it's think about an antibody. Think about only the antibody. Now, what do you guys say? What does an antibody do?
It fights an antigen.
Yeah, it finds an antigen. Now, let's say that antigen is a thyroid receptor. Now, if a random antibody which has decided that it will bind to the thyroid receptor as the antigen goes and binds to the thyroid receptor, what do you think will happen to the receptor?
It just becomes blocked.
It'll become okay, yeah, it can become blocked, but like a majority of the times it will become activated, like a permanent binding and a permanent activation. Now, because there's activation of this, because there's this interaction and now there's activation, so you'll see hyperthyroidism. That's the mechanism of action for Graves' disease, which is a type 2 hypersensitivity reaction. Now, let's say the antibody which was produced, it binds to an antigen and it releases some cytokines. Binding to the antigen releases some cytokines. What do you think will happen then?
An inflammatory response.
Yes, and you'll see the macrophages, you'll see the lymphocytes come in. maybe the natural killer cells come in, maybe the cytotoxic T cells come in. But these cells will come in, and what these cells will do is they'll kill the surface, which is probably a cell. So they'll kill the cell which has the antibody on top of it. So that is called cellular destruction. And if the NK cells are involved, that's called this one, antibody dependent cellular cytotoxicity, because you need an antibody for this. We already said that binding of antibodies can cause inflammation. So if there is antibodies binding to a surface, you can see inflammation. Yep. And this one is what we talked about when antigens bind to an antigen, which is actually a receptor. So now tell me, what is a method that we can use to detect antibodies in the blood?
Coombs test.
Yeah. So Coombs test. So for type 2 hypersensitivity reactions, we can perform a Coombs test, either direct, either indirect, but you can perform a Coombs test. So what do you guys have? Did you understand type 2 hypersensitivity reaction?
I will when I watch the recording.
Okay. But if you come across any point that you did not understand, you can text it in the group. Or if you don't want to text it in the group, you can also text me on personal, and I'll try to, help you get through the topic.
No problem, will do.
Perfect. Okay. So we discussed that type 2 hypersensitivity reaction was because of an antigen. Now type 3 is because of an antigen and antibody complex. So it's because of an immune complex. Oh, sorry, this should be green. Actually, wait, I'll have to mark all of these as red. That is the most important thing you need to remember for this. Yeah. So type 3 hypersensitivity reaction. Now you have immune complexes. Now, what can an immune complex do? What do you think? What's the most noticeable thing an immune complex can do? It will deposit. It can deposit in the liver. It can deposit on uneven surfaces, maybe in plaques, most commonly the kidney, but it will deposit in random places in the entire body. The immune complex. Now, if the immune complex deposits anywhere, you will have inflammation around that area. That is the entire uh, idea behind a type 3 reaction. Type 2 was very targeted. It was against a specific antigen. But type 3, it's wherever the complex can deposit. So let's say you develop serum sickness. Now, serum sickness is a condition in which, sorry, it's a flu-like syndrome that you can develop maybe after you take some medication, and then because of that medication, you can develop serum sickness. And it's usually because of like small proteins which are present in the medication which your body does not properly break down. They get attached to a molecule, it causes activation, all of these things. But serum sickness happens because of medications. Now, someone took a medication, had serum sickness, their body produced a lot of antibodies, they deposited in various locations, and then because of the deposition, they developed symptoms. Now, let's see the symptoms. They'll be pretty non-specific. You'll have fever because of the inflammation, you'll have urticaria because of inflammation on the skin, you'll have arthralgias because those antibodies got, not antibodies, but those complexes got deposited in the joints. You'll have proteinuria. Why? Because the kidney is affected, because kidney has a lot of deposition. You'll have lymphadenopathy. Now, why do you think we have lymphadenopathy in these cases?
Could it be because of the deposition of the immune complexes
It's because of
into
the
the lymph
immune
nodes?
complexes. You know, now your body, it's producing a lot of immune complexes. I mean, it's producing antibodies, it's also producing antigens. They bind together, you have an immune complex. But basically, your body is working overtime to produce immune complexes. Now, where are immune complexes produced? By which cells? B cells. Where are B cells? Lymph nodes. So, lymph nodes will increase in size. That's why lymphadenopathy. Then we have Arctus reaction. Now, Arctus reaction, that is also something similar. There's one thing that you need to remember for Arctus reaction is that it's local in a specific area, and the reason why it's local is because like it's like in the skin, so it doesn't really have space to go anywhere. That's why. Oh, and this is actually important. You know, I was telling you that there are small molecules which bind to the medication, and then they set off a chain reaction which leads to serum sickness and serum sickness like syndrome. So those are called haptens, and that is the buzzword you need to remember. Finally, we have type 4 hypersensitivity reaction. Now, type 4 hypersensitivity reaction, there is if there is only one thing that you need to remember that they rather involve the T cells. Now, what type of T cells do we have? We have CD8 positive T cells, which are called cytotoxic T cells, so they can directly go and kill a cell. That's one mechanism. So you have direct cell cytotoxicity. And then we have CD4 positive cells, which can mount a different immune response by producing a lot of cytokines. So that's the second mechanism, which you have the inflammatory reaction. Now, one thing to know, right, is that because it's T cells, so you won't produce any antibodies because it's not the T cells which are producing antibodies. Now here you had here you had an antigen antibody complex, the immune complex. Here you had antibody production. Here you had antibody production or immunoglobulin production, which is still an antibody. So all three of these, you had antibodies. Now type 4 is the only one where you don't have any antibodies. And then if I were to tell you the best example, that would be contact dermatitis. And then remember that PPD or like the skin test that we do, the Mantox test, they all follow a similar mechanism as type 4 hypersensitivity reaction. So you put a small antigen subcutaneously, and then the T cells they migrate towards the site. And then based on how many T cells migrated, you can confirm if the patient has the infection or if the patient does not have the infection. Now, one last thing. Because T cells are getting involved, how much time do you think it will take to develop contact dermatitis? Will it be slow or will it be fast?
Fast,
Why fast? Because lymphocytes are getting activated.
direct contact. Yeah.
It
Direct
will be
contact,
slow.
yes. They'll be very slow
Okay,
because
lymphocytes.
lymphocytes take time to get activated. So it will be delayed. The onset will be delayed. Maybe you get the contact today. Maybe the rash that you get will be 2 or 3 days later, but it's
Oh,
delayed.
it's that delayed.
Yeah, no, I mean, that was an example. Maybe, it can be 24 hours delayed, but it is delayed.
Okay.
That's the idea. So those were all the hypersensitivity reactions. So any questions about these hypersensitivity reactions or even with vaccinations?
Not
No.
now.
Not now. Okay. So I
Yeah, not now because when I saw the questions only then I know this topic, I get many questions wrong in these two topics.
Yeah. So don't worry. We will go through these
But it's
questions.
been a while, so yeah.
Yeah. So we will go
So
through these
once when
questions
I'll
too.
show. Okay.
Okay, then let's end our session for today.